This is lesson 73, VHDL example 46, and in this example we'll write a VHDL program for a ring counter. Here's the circuit for a ring counter, you remember, and so we'll have inputs clock and clear and output Q. Remember, we connect Q0 back into D so that we're going to connect this clear into this set you see here. So to do that, we will be able to then have a 1. We'll start out with 0, 0, 0, 1, so we'll get something in our little ring counter. So to do that, we need the signal QS like we had for the shift register. So this is very much like the shift register. The only difference is that instead of clearing QS, when clear goes to high, we're going to have QS go 0, 0, 0, 1. That will start a 1 going in here, you see. Else on the rising edge of the clock, remember clock tick event and clock equals 1 is the rising edge of the clock. Q3 now gets Q0, so Q3 gets Q0, and then QS2 down to 0 gets QS3 down to 1. And then we set QS, Q to QS. Here's the simulation. We have a clock and asynchronous clear, and you see what Q is. The first Q3 on clear, Q0 starts at 1, and then on the next rising edge of the clock this Q0 goes into Q3, and then what used to be in Q3 goes to Q2 and so forth. Then on the next rising edge of the clock this Q3 goes to Q2, and what was in Q0, which is now a 0, goes into Q3. So this 1 bit gets shifted from Q3 to Q2, Q1, Q0, and then back to Q3, Q2, Q1, Q0. And so you see we end up with basically 4 clock signals. Q3, these are clock pulse trains, and notice they're offset by 1 clock period. So we basically have a 4-phase clock. So that's an application of a ring counter.